All right, everybody. So today we'll talk about just-in-time 10.5 and 10.6. So 10.5 is just rationalizing a numerator or denominator using conjugates. Okay, so a conjugate is formed by changing the sign between two terms in a binomial. So for example, if I have x minus the square root of 3, the conjugate of that would be x plus square root of 3. All right, so we use that when we have something like this where we want to, if we've got a square root term and we want to rationalize it to get rid of the square root or to just move it so it's in the numerator and not the denominator, or vice versa, we can multiply by the conjugate. So in this case, we want to rationalize the denominator, so that's what we're going to take the conjugate of. So our conjugate of that is going to be x minus square root of 3, and so we multiply both the numerator and the denominator by the conjugate. And so that should give us x squared minus 3 times x minus root 3 divided by x squared minus 3. Okay, generally when you're multiplying by conjugates, whatever that first term is, it'll just be that squared, and then whatever's under the square root, it'll just be minus that, generally. We can also rationalize the numerator. So this one, it'll be a two-step, so we first have to combine them into one fraction. So we can do that, and that gives us square root of x minus square root of x plus h over square root of x times square root of x plus h. Okay, and looking at this, you may feel like you want to attempt to rationalize the denominator, but there is no addition or subtraction in between these two radicals, so you cannot rationalize that. So we're rationalizing the numerator, okay, and our conjugate's going to be just root x plus h. Multiply both the numerator and the denominator by that. Okay, and that gives us x squared minus root 3. After some, oh, sorry. I was looking at the wrong problem. All right, so that should give us x minus x plus h over root x plus h times root x plus h, which gives us just negative h over x root x plus h plus root x times x plus h, if we distribute this to both these terms. Okay. So there's rationalizing. Just-in-time 10.6 is just extracting factors from radicals. Okay. So if we're looking at a root like this, and in this case, we've got a root of order 3. If we have any powers of 3, we can pull those out. So what we want to look for is look for powers of 3 in there. So we can break up 250 into 2 times 125. Break up our x to the 4th, and that'll give us an x to the 3rd times x. And then we leave y to the 3rd alone. And then we know that 125 is just 5 to the third. So then that gives us with a 5 to the third, an x to the third, and a y to the third. All three of those can come out. Okay, so those would be 5 times x times y, because the root cancels the exponents, times whatever was left behind, so 2x in this case. Okay. Sometimes you might have a special case. So with odd roots, this won't ever happen, but with even roots, sometimes if you're pulling out something that's the same order, then you'll need to put absolute value on it. So we'll do an example like that here. So here we're looking at, in order to pull it out of the exponent and cancel, it's got to be factored out of this. Okay, so we're looking for what can I pull out of both of these? So I can pull out an x squared. I can also pull out a y to the fourth, which is y squared squared. Okay, so factoring that out, I'll factor out my x squared and my y to the fourth, and that'll be times y to the y squared plus 3x to the third. Okay. Now, here's where that special case comes in. Because I've got the square root of x squared, and that would cancel to an exponent of 1, or because it cancels completely, we have to write this as the absolute value of x. Okay. And then y to the fourth comes out, and that's just y squared. Because we still have this squared left, we don't have to do the absolute value. There's still some power left. It's only when you completely clear the power of an even order that you have to use the absolute value. Okay, and then we're left with square root of y squared plus 3x to the third. Okay, so if you clear an even root completely, that's when you need to use that absolute value. Okay, odd order, it doesn't matter, but even it does. All right, if you've got questions, you can ask me in class or email me.